Hello everyone, I am Tanata of Nibida ILBC, and today I'll be explaining the application of calculus in our life and medical research. So this is the outline of the presentation. These are just the topics and not the slides, just so that you can have an overall idea of what will be presented in this presentation. So, calculus. What is it? Calculus is the language of mathematicians and the universe. It was formed in the 17th century by Isaac Newton and Gottfried Leibniz, and it is debated which of them actually started or developed calculus. But let's assume that both of them developed calculus. And it is originated from the Latin word calculus, which means a small pebble used for counting, and it makes a lot of sense as calculus is also like another way of counting. It studies the effects of changing conditions in a system. This means that it studies how things change and what the effects of the changes are in a system. So, calculus can be used to study anything with the rate of change. And it is from the form of mathematics that is developed from algebra and geometry and have two interconnected topics: differential calculus and integral calculus. This is differential calculus. It studies how things change when considering the whole to be made up of smaller quantities, and with this we can find the instantaneous rates of change and the slopes of curves, as well as maximum and minimum points. Here is an example of differential calculus, which is very simple, and it is actually from our textbook. So I'm sure everyone can understand at least this form of differential calculus. But basically, differential calculus deals with all the small parts that make up the whole system, and it breaks things into smaller quantities so that we can determine how the small changes affects the whole. On to integral calculus. Integral calculus studies the whole system as an accumulation of smaller quantities or components. With this, we can calculate the accumulation of quantities and the areas under or between the curves. And an example here is also a very simple calculation of integral calculus. And integral calculus puts together smaller quantities to determine how the whole system is formed from the smaller bits and how it is affected by small changes. And here are the types of applications of calculus, because we often wonder to ourselves, why are we learning calculus? I can't see myself using it in my daily life. Well, obviously, a wide variety of careers regularly use calculus. Universities, the military, government agencies, airlines, entertainment studios, software companies, and construction companies are just to name a few. But here, for example, credit card companies use differential calculus to set the minimum payments due on credit card statements. Because in order to set the minimum payments due on credit card statements, they need to use differential calculus to consider different variables such as the changing interest rates and the fluctuation currency values before actually setting the payment due time. And for electrical engineers, they need to use integral calculus to determine the exact length of the power cable that is needed to connect two substations that are miles apart. And because they're miles apart, of course, there are going to be some curves. And by using integral calculus, we can find the precise figure or the precise area between the curves so that they have a better understanding of how to work the cables. And for architects, they need to use integral calculus to determine the amount of materials necessary to construct a curved dome over a new sports arena. And for space flight engineers, they need differential calculus to plan lengthy missions, as they need to consider factors such as the different orbiting velocities of the Earth and other gravitational influences like the sun or the moon. And for statisticians, they need differential calculus to evaluate survey data and help develop business plans for different companies. This is because a survey involves many different questions with a range of possible answers, and using differential calculus allows a more accurate prediction for for the statisticians to be able to give proper business plans for the different companies. And for physicists, they need calculus to find the center of a mass of a sports utility vehicle. And for graphic design artists, they need differential calculus to determine how different three-dimensional models will behave so that they can create the most realistic type of images after considering the different speeds and how the environments can change by using differential calculus. And now on to medical research. How can we use calculus in medical research? Now, it can be used to measure the blood flow, the cardiac output, the tumor growth, and the determination of the population genetics in in sectors such as biology and medicine. And it can also be used to determine the exact rate of growth in bacterial culture when different variables such as temperature and food source are changed. So we need this research or these statistics by using calculus so that we can either increase the growth of the useful bacteria or decrease the growth of the bacteria once it becomes harmful or potentially dangerous. And doctors, they need calculus to help build the discipline necessary for solving complex problems, such as diagnosing patients by monitoring the rate of their conditions. Some examples include cancer, because doctors really need to study the condition of the patients before diagnosing them with a condition as fatal and as important as cancer. And the last one may sound familiar to you, epidemiology. It determines how far and fast a disease is spreading, where it may have originated from, and how to best treat it. We use calculus for this, and this situation may sound familiar, as we're also living in a pandemic. And the only difference between epidemic and pandemic is the amount of areas reached, and we're in a pandemic, which means it reached the entire world, where epidemic is only in, the places around where it originated from. And they need to use differential calculus when studying epidemiology. Here's an example that I found where an Indian university used calculus to build a mathematical model of COVID-19 so that they can control the rate of transmission in India and maybe decrease the rates of transmission. On the left, we can see different uses of integral calculus and differential calculus. It looks very complicated and hard to understand, but the main idea is that they used calculus to form these graphs on the right, which shows the dynamical behavior between the recovered population and the infected population. And these diagrams really help people who are studying epidemiology to control and have a better idea of how COVID-19 works, as it is a very new disease. And here are more explanations, but I'm not going to go too deep into it, as I personally don't understand much. I just know that they're using calculus so that they can control the rate of spread or have a better idea of the rate of spread of COVID-19 in India. So, the summary is that calculus is a study of changing conditions in a system, and differential calculus breaks it into smaller pieces to determine how they affect the whole, whereas integral calculus puts together the smaller pieces to form a whole system and how it is affected by the small changes. The different applications have been listed, and the application of calculus in medical research was explained in the example. Here are some references and source materials that I used for this presentation. We have reached the end of this presentation, and I would like to thank you for listening to this, and I hope that you have learned something about the application of calculus in our life and in medical research.